everyone, I'm Ma'am De Jesus and this is our math class. Hi everyone, so today, this week is our third week in quarter 3. So before we proceed with our new lesson, let's have a very short activity first. Are you ready? Let's start. So our activity class is what we called Patdaan Please. Alright, so allow me to explain how this activity works. Our task class is to help our delivery rider reach his destination the fastest way. So, how do we do this? I will be showing a map class where the rider is and his destination. All you have to do, class, is to point out the ways to reach his destination the fastest way. I will be giving you 5 seconds to answer each map. Are you ready? Let's start. This is the map which shows the rider's location, and where the arrow points out is his destination. On this map class, the rider's location is on Archimedes Road, and his drop-off point is on the house on the left side of Tartaglia Road. What is the fastest way to get into his destination? You have 10 seconds to answer. Very good. Go straight to Archimedes Road, then turn left to Tartaglia Road. Very good job, class. Alright, on this next map, the rider is on Goss Street, and his drop-off point is the house at the Einstein Street. What is the fastest way to get in his destination? You have 10 seconds to answer now. Great job! Go straight to Galileo Road, then turn left to Pascal Road. Great job, class! So, class, this is the last delivery of our hard-working rider. He is at the Court Road, and his drop-off point is the Blue House at the Euler Street. What are the best ways to reach his destination faster? You have 10 seconds to answer now. Good job! Go straight ahead at the Court Road, then turn right to Pascal Road. Congratulations, everyone! You did a very good job, class, in our activity. And of course, this activity has something to do with our lesson for today. But before we start, let me tell you what we are aiming to learn after the discussion. So let me tell you our objectives. First one, class, is of course to define the parallel lines and a transversal. Secondly, illustrate the angle relationships formed after parallel lines are cut by a transversal. And the third and last, class, is to solve for the measurement of the missing angle after parallel lines are cut by a transversal. Okay, so going back in our activity class, let me show you the map that we used a while ago. This map have pairs of lines that are very familiar to us. Take a look at it. What are the pairs of lines that you can see on the map? Good observation, class. There are parallel lines and intersecting lines. Can you give me some example of parallel lines that you can see on the map? Very good. So the Court Road is parallel to Galileo Road. Same as with Tartaglia Road is parallel to Pythagoras Road. Very good observation. How about class, the intersecting lines that you can see on the map? Very good. Pascal Road intersects Descartes Road and Galileo Road. Very good. You remember the past lessons very well. We tackled this because our topic for today is very much connected to our lesson, and that is parallel lines cut by a transversal.
So class, welcome to the discussion part of our lesson for this week. And like what I have told you a while ago, our lesson is all about parallel lines cut by a transversal. Okay, so before anything else, class, of course, we have to define what are parallel lines and transversals. So first question would be, what would you call two lines which do not intersect? Very good, class. That is what we call parallel lines. So meaning to say, class, no matter how we extend the lines on both sides or both ends, they will not intersect or they will not meet each other. So a solid arrow, class, is placed on two lines of a diagram. These will indicate that these two lines are parallel. So the symbol, the two vertical lines, is used to indicate that the two lines are parallel, like what you can see on this figure. So in this case, how do we use this? Line AB, class, is parallel, so this is how we read this, is parallel to line CD. And of course, class, these parallel lines have parts formed. So those who are outside the parallel lines, these are what we call the exterior. And those parts inside the parallel lines is what we call interior part. So class, a slash through the parallel symbol like this, if you see a slash on this symbol of parallel lines, meaning to say, it indicates that the lines are not parallel, like what you can see on the figure. So line AB, class, this one, is not parallel to line CD. Next one, class, what is a transversal? So a transversal, class, is a line, ray, or segment that intersects two or more coplanar. When we say coplanar, class, these are undefined terms that belong in one plane. Okay, they all belong in one plane only. So again, when we say transversal, it is a line, ray, or segment that intersects two or more coplanar lines, coplanar rays, or coplanar segments. Like this one. Okay, so as you can see, class, this line, okay, intersects the two parallel lines, and these parallel lines are coplanar. Okay, and these are not parallel lines. So meaning to say, class, transversal can be written whether we have parallel lines or non-parallel lines. So transversal can be written or can be drawn. So as you can see, once lines are cut by a transversal, parts are formed. We have exterior part, we have two exterior parts, and one interior part. Those are inside the lines, okay, or on this part, inside the parallel lines. So a transversal, class, is a line which intersects two or more lines in a plane. The intersected lines do not have to be parallel. So this is what I have told you a while ago. Okay? So you can draw transversal whether lines are parallel or not. So again, these are the parts formed when we have parallel lines and transversal. So the space inside the two lines, class, is what we call the interior. And of of course, exterior, from the word exterior, the space outside the two lines. So these are the exterior part. Take note of this. We will be using this a lot later. So, once parallel lines or non-parallel lines are cut by a transversal, special angle relationships are formed. So take a look at this one, class. Okay? So we have what we call, class, the interior angles. So like what I have told you a while ago, interior is on this part between two lines, okay? And of course, those angles inside this part is what we call interior angles. So angle 3 and angle 6, class, are alternate interior angles, meaning to say alternate one angle from both sides or each side of transversal. Can you give me another alternate interior angles? Very good. So angle 4 and angle 5, class, are also alternate interior angles. Okay? While angle 3 and angle 5, class, are interior angles also, but on the same side of transversal. So as you can see, the location of these two angles are on the same side of transversal, but still, these are interior angles. Can you give me another interior angles on the same side of transversal? Good job. Angle 4 and angle 6 are also interior angles on the same side of transversal. What do you think will be the next special angle relationships? We have interior angles, and we are now expecting the... Very good. We have also exterior angles. Can you please name what are the exterior angles? Very good, class. These are angle 1, angle 2, angle 7, and angle 8. So if in interior angles, we have alternate interior angles. Also, in exterior angle, we have what we call alternate exterior angles. Can you give me an example of alternate exterior angles? Very good. So we have angle 1 and angle 8 are alternate exterior angles. Very good, class. You can easily follow the lesson. Can you give me another example of alternate exterior angles? Great. Angle 2 and angle 7 are also alternate interior angles. So, if in interior angles there are alternate and same side, also in exterior angles we have alternate and very good, same side exterior angles. So can you please name one pair of same side exterior angles? Good job. Angle 1 and angle 7 are same side exterior angles or exterior angles on the same side of transversal. Can you give another pair of same side exterior angles? Great. So we have angle 2 and angle 8. Good job, class. So also, class, special angle relationships are formed when the lines are parallel. So once parallel lines are cut by a transversal, there is a very special angle relationship that exists only if the lines are parallel. Okay, class? What we discussed a while ago, the special angle relationship can be applicable in any lines once intersected by a transversal. But on this part, this is only applicable if the parallel lines or if the lines that was cut by a transversal were parallel lines. Okay? Again, this is only applicable if the lines are parallel cut by a transversal. So take a look at the figure we have. So first special angle relationship class when the lines are parallel, alternate interior angles are congruent. Meaning to say, class, if we have congruent, the measurement of two angles, of two alternate interior angles are congruent. So let us say angle 3 and angle 6 are alternate interior angles. If angle 3 measures 60 degrees, angle 6 measures also 60 degrees because they are congruent. Again, always class, when the lines are parallel and cut by a transversal, alternate interior angles are always congruent. Congruent meaning to say they have the same measurement. Next one, class. If alternate interior angles are congruent, also alternate exterior angles are also congruent. So in this case, if angle 1 measures 100 degrees, therefore angle 8 is also 100 degrees since they are alternate exterior angles. Next one, class. Same side interior angles are supplementary. When we say supplementary, class, if we add the two angles, they are always equal to 180. Okay, so same side interior angles, so angle 3, those are angle 3 and 5 and 4 and 6. They are supplementary, meaning to say if we add them, they should be equal to 180. Okay, so if angle 3 is 60, therefore angle 5 is 120. Because 120 plus 60, that would be equal to 180 degrees. And that's what supplementary means. Also, class, same side exterior angles are also supplementary. So, as you can see, class, they are very easy to remember. If they are alternate interior or alternate exterior, they are always congruent. But if they are on the same side, they are always supplementary. Okay? Supplementary meaning to say if you add the two angles, they are always equal to 180. Again, alternate, they are congruent. Same side, they are supplementary. So if the lines are not parallel, class, again, these angle relationships do not exist. These are special only when the lines are parallel. So next part, class, when parallel lines are cut by a transversal, again, when parallel lines cut by a transversal, we also have what we call corresponding angles and consecutive angles. So corresponding angles, class, these are two angles that occupy corresponding positions. What are these pairs of angles? Take a look at this one. We have angle 1 and angle 5. Can you give me another one? Very good. We have another 3, angle 3 and angle 7 are also corresponding angles. Very good. Angle 2 and 6 are also corresponding angles. And for the last one, angle 4 and angle 8 are also corresponding angles. So one special description of corresponding angles, class, they are also always congruent. They have the same measurement. So class, as you can see, angle 2, whatever the measurement of angle 2 is also the measurement of angle 6 because they are congruent and they are also corresponding angles. Angle 1 and angle 5 are corresponding angles, so therefore they are congruent. Same as with angle 3 and angle 7 and angle 4 and angle 8. So when two parallel lines are cut by a transversal, pairs of corresponding angles are formed, like what I have told you a while ago. There are 4 pairs of corresponding angles, class. Again, 4 pairs. In alternate exterior, we have only 2 pairs, while same side has also 2 pairs. In corresponding angles, class, we have 4 pairs of corresponding angles. And of course, they are always congruent. They have the same measurement. So in this case, class, please take a look at the figure that you can see here. So line M is parallel to line N, and line L is our transversal. Okay? So angle GPB, this one, the pink one, is equal or congruent to angle PQE. So take a look at those. They are the shaded part. They are congruent because they are corresponding angles. Same as with angle GPA, this one, and also angle PQD. Since they are corresponding angles, therefore, they are congruent. Also, angle BPQ, here BPQ is equal to EQF. Take a look at this one. Because, again, they are corresponding angles. Take a look at the figure. And last one, class, we have APQ. APQ, this part, this angle, is also congruent to angle DQF. Because, again, they are corresponding angles. So as you can see, class, when parallel lines are cut by a transversal, we have 4 pairs of corresponding angles, and they are all congruent to each other. So we have same side interior and same side exterior angles, class. So like what I have told you a while ago, same side interior and same side exterior are supplementary. Okay, these are 2 angles that lie between parallel lines and on the same side of transversal. So those are, on this part, interior, what are the same side? We have angle 3 and angle 5, and, very good, angle 4 and angle 6. How about the same side exterior? Very good, we have, so before that, class, like what I have told you, again, same side interior or same side exterior are always supplementary. So if we add angle 3 and angle 5, they should be equal to 180. Same as with angle 4 and angle 6, they should also be equal to 180 when added. Okay, same side exterior, class, these are 2 angles that lie outside the parallel lines on the same side of transversal. So your answer a while ago is correct. Angle 1 and angle 7 are exterior angles, same as with angle 2 and angle 8. And also, class, again, when they are on the same side, they are always supplementary. So therefore, the measurement of angle 1 plus the measurement of angle 7 should be equal to 180. This rule applies also to measurement of angle 2 and measurement of angle 8 should also be equal to 180. So for you to be able to memorize it quickly, if this is alternate, they are always congruent. If they are on the same side, they are always supplementary. So we have, class, interior angles. So these are the angles that lie in the area between two parallel lines that are cut by a transversal are called interior angles. Okay, so these are the interiors. So we have been tackling this since a while ago. Okay, so these are same side interior. So as you can see, class, alternate interior angles have the same color. It is because they have the same measurement. The measure of interior angles in each pair here on the same side add up to 180. Again and again and again, class, if we are talking about same side, it's always supplementary. And if we're talking about alternate, it's always congruent. So for instance, this angle is 60 and this one is 120. What do you think will be the measurement of angle APQ? Again, they are equal to 180. So the measurement of angle APQ, since they have the same color and alternate, they also 120 and 60. There. So they should always be equal to 180. So alternate interior or exterior angles, class, two angles that lie between parallel lines on opposite sides of transversal but not a linear pair. Remember, class, alternate interior are not linear pair. They're just on the same side of, on each side or opposite side of the transversal. So we have 3 and 6, 4 and 5. We have been tackling this a while ago. So angle 3 is congruent to angle 6. Again, when we're talking about alternate, it should always be congruent. Okay. Take a look at this. Angle 2 is congruent to angle 7 because they are alternate exterior angles. Angle 1 and angle 8 is congruent to each other because they are alternate exterior angles. Okay, so again, alternate interior angles are formed on opposite sides of the transversal at different intersecting points. Okay, alternate, class, they are not linear pair. Remember that. Okay, angle BPQ is equal to angle DQP. This one. Okay, and next one, class, angle APQ, this angle, is congruent to angle EQP. So, a while ago, we have 4 corresponding angles, and right now, we have 2 pairs of alternate angles. Alternate exterior, 2 pairs. Alternate exterior, 2 pairs. And they are always, class, remember this, congruent. Once we talk about alternate, class, it's always congruent.
Okay, so class, we are now done with our discussion about the topic parallel lines cut by a transversal. And I am greatly hoping, class, that you learned something from the discussion that we had a while ago. And of course, to sum up our discussion, class, let's have a game called Truth or Change. All you have to do, class, is to say truth if the statement about the parallel lines cut by a transversal is correct. And of course, otherwise, you have to say change. Then, we have to change the underlying words to make the statement correct. Are you ready? Alright, so let's start the game. So for this activity class, please refer to the given illustration here. Alright, let's have the first statement. Angle 1 and angle 3 are corresponding angles. Truth or change? Very good, class. The answer is truth. Angle 1 and angle 3 are corresponding angles. Let's move on to number 2. Angle 2, angle 6, angle 3, and angle 7 are exterior angles. Again, angle 2, angle 6, angle 3, and angle 7 are exterior angles. Truth or change? Good. Change. And what is supposed to be the answer? Very good, class. They are interior angles. Very good. Next one. If the measurement of angle 6 is 75 degrees, then the measurement of angle 8 is also 75 degrees. Truth or change? Again, if measurement of angle 6 is equal to 75, then the measurement of angle 8 is also 75 degrees. Truth or change? Good job, class. The answer is truth. The next one, number 4. Alternate interior angles are supplementary. Again, alternate interior angles are supplementary. Truth or change? Good job, class. That is change. And what are we supposed to do now? Or what are we supposed to write? Because alternate interior angles are congruent. Good job. And for the last statement, class, exterior angles on the same side of transversal are congruent. Again, exterior angles on the same side of transversal are congruent. Truth or change? Very good. The answer is change. And what are we supposed to do, or what are we supposed to write? Yes, that is correct, because exterior angles on the same side of transversal are always supplementary. Good job, class. So class, I am so happy that you are learning a lot and fast. And with that, let's have our activity time. And this activity class is called Size the Day. Okay, so how do we do this activity, class? Given the illustration here, all you have to do, class, is to find the measurement of the missing angle that will be flashed on the screen. Again, all you have to do is to find the measurement of the missing angle that will be flashed on the screen. And that is only based on the illustration that will be shown later. Okay, so let's have, before I forget, you have 10 seconds to answer. Okay, so given, class, angle 5 is 105 degrees. What is the measurement of angle 7? Good job, class. The answer is 105 degrees. Why? Because angle 5 and angle 7 are corresponding angles. Very good, class. Let's move on to number 2. What is the measurement of angle 2? You have 10 seconds to answer now. Great. The answer is 105 degrees. Again, why? Very good, because angle 2 and angle 7 are alternate interior angles. Okay, class, let's move on to number 3. What is the measurement of angle 4? You have 10 seconds to answer now. Nice one, class. That is 105 degrees. Why is that so? It is because angle 2 and angle 4 are corresponding angles. Okay, let's move on. Next one. How about the measurement of angle 3? 10 seconds. Good job, class. The answer is 75 degrees. And why is that so again? It is because angle 2 and angle 3 are interior angles on the same side of transversal. And for the last one, class, what is the measurement of angle 1? Yes, that is correct. The answer is 75 degrees. And why? Again, it is because class angle 1 and angle 4 are exterior angles on the same side of transversal. Job well done, class. Congratulations. Alright, class, we are now almost done with our discussion, and I would like to congratulate everyone for reaching this far. And of course, to test the learnings that you had after the discussion, I want you to open your module on page 6 and answer the following parts. First one is the check your understanding, and the second part is the post test. Again, answer check your understanding and post test on your intermediate paper. This will be submitted on the retrieval date. Alright, class, we are now down to the last part of our discussion. And for this part, I want you to paste this link on the browser and play the game that can be found on the site. Right? Just remember, class, after playing, make sure to screenshot your score and send it to our GC. Okay? If you still have questions or clarifications, you may go back to the discussion part of this video lesson, or you may directly ask me in our GC. So that would be all for today, class. Thank you, congrats, and annyeong!